I'd like to welcome you all to our talk on migrating to AES. As you've seen, we've gathered an all-star cast for you. Richard Kisley, Chief Engineer, Stephen Bowles, Regional Security Officer, and myself, Senior Cryptographer. So before we dive into any of the technical details, the PCI committee was very insistent that we start by explaining to you what is AES. Now, I'm sure for many of you, this is a well-known thing, but for those who aren't, computers get faster every year. That means that we need to change our cryptographic algorithms periodically to keep ahead of the security curve. AES, the Advanced Encryption Standard, is the current gold standard for protecting data. This is not a new standard. This has been the US standard and a standard used throughout Europe and other parts as well for over 20 years. But those of us in the banking space know that ATMs, point of sale terminals, chip cards, we don't change that technology until we absolutely have to. Well, one of the bad news of this talk is, yes, we are getting to the point we absolutely have to move. So our job today is to tell you how to do that. So first, Richard is going to talk about the current state of AES support in payments. What are the requirements and the mandates that are there out there right now? And what do we see that is coming? And what progress has been made in using it already? Then I'm going to talk a little bit about the ongoing work in standards. What tools do you have to work with right now? And what pieces are still missing? We've got to finish up our standards work. And finally, Stephen will talk about what you need to do to move on your AES migration. What decisions should you make today or you should have already made? And what do you need to, where do you start? So with that, I will hand it off to Richard.
All right, thank you. So starting out, look, what's the current state from requirements and implementation? All right, so starting out with PCI, of course. PCI PTS, looking at the device support. PCI PTS HSM and POI were updated in 2016 to require AES support. So it's there. Most of you probably already have it in a significant portion of your devices. So what about requiring it to be used from an auditor of the folks that put it in practice in the payment network perspective? PCI PIN, so there was an AES Sunrise put in 2018, and that was January of this year. And then it was changed in 2021 so that there's not currently an AES Sunrise expectation from PCI. Now, I do have a couple unrelated notes at the bottom. They are actually related from a cryptographic perspective. AES operational keys, just a level set, require AES device master keys and master file keys, whatever term you want to call those, and AES key encrypting keys for key exchange. What's definitely not compliant is encryption of AES keys with TDES keys. They're just not strong enough. Also not compliant, encryption of AES 192 or 256-bit keys with RSA 2048 keys. Now, if you know your cryptography well, AES 128 is actually stronger than RSA 2048, but there's a little bit of an exception there, just because everyone uses RSA 2048. But for the two bullet points above, just don't do that. Don't wrap AES 192 or 256 with RSA 2048. It's not strong enough. So other organizations, Ingenico has already spoken at this conference, and their standards are up to date for interoperability for AES and elliptic curve. So it's out there. Some of those are updated as recently as March of this year, but that support in progress has been moving for quite a few years, actually, since several years before COVID. Payment brands, though, no public requirement for AES, no public sunset of TDES. NIST, on the other hand, is not silent. NIST is saying at the end of this year, stop using TDES for encryption. OSPayNet brought up because they really punch above their weight in the global market for security practices and security requirements. They view ATMs and payment networks as critical infrastructure. And so sunrise of AES is expected to be 2026. Sunset of TDES expected to be around 2030. Why move other takes, right? Current status of motivation. Just again, from a cryptography perspective, TDES, for a 168-bit key, the security of that's reduced to 112 bits due to the birthday attack. Single DES was broken in 1997. If that sounds like a long time ago, it was a long time ago. AES is faster and more secure. Another viewpoint, legal. In 1998, a German court said that single DES was too weak for bank cards. 1998, and they ordered a bank to repay a customer's stolen funds. Now I have your attention. Liability, right? Look at that. Single DES was broken in 1997. That court case was in 1998. The speed of liability, right, is very fast. Might be faster than you expect. Implementation progress. So I'm an ISO participant. I took an informal poll across some ISO participants, people focused on payment security, and these are the results across the next couple slides. And so the red dots, those are people that are kind of relying on the device update cycle to get AES into the marketplace. The orange dot, that is someone that also has industry association support to have that move in their marketplace. The yellow dot, that's where they have government support. In addition to the industry association, and that's on Australia, as noted. The green dots, they also have projects well underway. So they have the support I mentioned, plus projects underway. I know I pressed this. Okay. Back to the poll, a little bit more details on this. So AES hardware is available, but the move to turn that on in your payment network, that's really up to who's going to drive it, payment schemes. Respondents, several respondents mentioned payment schemes should be driving this, driving the move to AES for people to turn that on in their networks. Regulatory, some markets, some respondents said there is regulatory backing for the move to AES, but that's certainly not the case in all markets. And that's definitely a significant driver, as you see from the map. So this is even more informing, right? Timeline. 2 of the people in this list have a timeline with an expected transition to AES of 2031. Nobody else in this list has an expected transition date. I think that's a very important takeaway. What are the blockers to transition? Are standards at fault? I don't think so, right? So AES interoperability is there in EMV code. There's quite a bit of support. There's one particular standard that we'd like to have out there from a standards perspective, and I'm in some standards bodies. AES PIN verification would be nice, but we've never had a PIN verification standard before, so I don't think that's a significant blocker. We would like, as device manufacturers, and you have a couple of them on stage, we would like as device manufacturers to have a PIN verification standard for the first time. That would be nice, but it's not a requirement for the industry to move to AES. Best practices, advise everyone starting a new project to use AES, please. I'll just, please, all right. Implementation progress. So secure devices, POIs, ATMs, HSMs, those are moving. The device support is there. To move the needle for real for the networks, again, we're going to talk a little more about standards, but payment scheme requirements, government involvement. Without more action, 2031 is the good case. And I'm pausing to let that sink in. That should be like, if you don't take away anything else from this talk, please take away that. Without any more action, 2031 is the good case. And we already talked about cryptography. The motivation is there. A sample program, AusPayNet, again, the Australian Payments Network. So transition points were identified, the switching to key blocks. They said, let's switch to AES when we switch to key blocks. Updating ATM protocols, let's use TR34, which can send AES keys, AES 128 keys, to ATMs securely. Critical infrastructure, again, I want to emphasize that point. They identified payment and ATM networks as critical infrastructure for critical to national security. I think that's a pretty good view, right? Isn't our payment network critical to national security? I would do a show of hands, but I kind of know the answer from this crowd anyway. So what's driving this? Again, it's an industry group with government backing. They're going to spend 3 years planning, and they're in the middle of the planning phase, actually. So and 7 years on the project. I think that's a great program to take as an example and to look at as, again, an example. Okay, I said example twice, 3 times, for others to look at and develop their programs.
Okay, so standards. As I mentioned, the standard's been around for 20 years. So the basic building blocks, how do you encrypt, how do you MAC, all those have been done for a long time. Data protection. Most of you are already using AES to secure your websites. TLS has been using AES for years. Key management, we have most of the pieces. We have unique key per transaction from a terminal to a host. We have the key blocks to do master session between hosts. There's been interest in having a lighter weight unique key per transaction host to host. That's in draft. The major piece that we're missing is a key block using elliptic curve. As Richard mentioned, you need to move from RSA to ECC as part of this migration. We have key blocks defined in TR34 for RSA. We do not have the equivalent key blocks yet for ECC. It's in committee. We're working on it. For pins, we're in great shape with the pin block. We don't have the pin verify. As Richard said, we've never had a pin verify standard, but it would be nice to have a standard so that people do this securely. For payments, EMV is up to date. However, they are silent about changing a pin, so sending an updated pin to a card via the secure messaging. The AES pin block does not fit into the secure messaging framework in the same way that the TDES pin blocks did. So while them being silent is nothing new, it does create some potential interoperability issues. The big thing missing in payments are those 3 to 5 digits on your card, the CVV, CVC, CSC. These have always been defined by the brands. Speaking as a vendor, I love it to be a standard so that there's one way to do it rather than 25. But yeah, no one has really, as far as I've seen, and I could have missed a document somewhere, a clear way to do that using AES. The biggest place where we're missing standards is in transitioning older devices. If you have an old device that didn't do remote keying, your options are to send it back to a facility and get new keys into it or throw it away. You can't send an AES key under a DES key. If you've got a terminal that will do remote keying, PCI PIN and PCI PTS have put in the exemptions that will let you use RSA to send a 128-bit AES key. That gets you that next step. However, your auditor considers that that key has been weakened to the same security level as a triple DES key, 112 bits. So how long they let you keep using that key is still up in the air. It's better just so that you're now all 100% on AES, but it's not as good as actually having a full AES at 128 strength or better. And there is some standards in the work that Stephen may talk a little bit about a possibility on that, but they haven't been approved. In addition to moving to the new stuff, part of a migration also means we stop some of the sins of the past. We've learned more and more as we study cryptography in the open community. So we have better techniques in many cases. CBC MAC needs to be replaced by CMAC. There's no point in doing the old way. Variants for key management. Cryptographers call these related key attacks. Sending a key without a key block. Mostly this is governed by PCI mandates. But even if you have a system that doesn't require key blocks, you should consider using it anyway. Sending a key without a key block is like paying for a shiny new AES lock on your door and putting the key under the welcome mat. You've just pretty much thrown away 90% of your security. PIN verification with the 3624 or offset method. This is a great method. 80 to 90% of people use it today. However, it is not secure if you change your PIN. We have to not do that when we move to AES. Finally, a PIN block that doesn't have either a PAN or a PAN link token as part of the calculation. ISO hasn't defined one. Do not define your own PIN block, please. So all in all, what do the changes mean? Pin block, it's simple. It's going to get twice as long. So your networks are going to have to change. The pin blocks are twice as long. Your key blocks are a bit longer. If you haven't moved to key block yet, then it's going to be a lot longer. You can see the ECB versus key blocks for TDA versus AES keys. The biggest change is going to be in public key, and it's going all over the map. Because when you go from RSA to ECC, things actually get shorter. This never happens. Cryptographers never get to do this for you. But in this case, yes, they're getting shorter. The bad news is post-quantum is also coming. And post-quantum, the signature algorithm recommended by NIST, that's the one on your far right there, that 2420 bytes. Yeah, not so short.
Thanks, Susan. Migration. How the heck do we get there from here? First things we all need to do is we need to understand what we've got in our environments. We've got to look at and do an inventory of our systems. What systems do we have that support AES today? If they don't support AES, is there an upgrade path with my vendor to upgrade the device I have? Or am I in that really sucky position where I'm going to have to toss it in the garbage and replace it with a brand new one? Not so, that's hard, no matter whether you're talking about POIs or HSMs. Yeah, POIs by themselves are cheap, but when you're talking about thousands of them, that's expensive. HSMs, you may only have a handful, but when those things are thousands of dollars each, tens of thousands of dollars each, that's a big pill to swallow. Once you've got that all figured out, you need to target your moves. Where are the systems in my network that are either critical infrastructure, are processing huge amounts of transactions, or, as Susan emphasized before, what things do I have that are still doing the old ROT13 encryption, right? So we've got to get those things out of our networks as soon as we can. I mentioned testing in here. Yes, a lot of our systems have AES implementations on them. Not all of those implementations have actually been used, nor used in an interoperable function with other technologies. I've already run into all kinds of implementations where the AES implementations were not necessarily exercised to their full function, and when you try to make them work together, they don't. So test, test, test. Get your stuff together, try it out, make sure it works, and get it there together. And as we talked about before, we do have this tie-in with post-quantum. We know we're going to have to do a similar sort of change. So a lot of these exercises are going to be repeatable. Ideally, we'd love to be able to do these changes at the same time, but that may not be possible. We may have to do the flip to AES first and deal with post-quantum at some point down the road. So this is just something we're going to have to make risk decisions about as we move along through the process. Upgrading keys. We've kind of hinted at it a couple of times. I don't know if you've heard it, but getting the new keys into your devices is probably one of the hardest things we're going to have to deal with once we start moving forward. There's two ways to get a key into a device: local key injection, and that's either manually punching the key material directly into the interface of the device, or connecting it to some sort of key loading device or secure cryptographic device and moving that key material across a wire into it. That's not so bad. It's a fairly straightforward process. Remote key injection, though, trying to get a key into a device that's in the next room, across the street, across the country, around the world. There's a principle here that's highlighted in purple around key management that Susan had talked about, where a strong key, if you encrypt it with a weak key, you have weakened that strong key to the strength of what you protected it with, right? So if you go and use a triple DES key at 112 bits of cryptography and you use that to protect your AES 256-bit key, you've wasted the effort of what you're trying to get to. So what the heck do we do? Well, that means you may have to physically visit all of your systems. Not so bad for HSMs. You probably only have a handful of data centers and you can get through that pretty quickly. Well, I say that quickly. But POIs, they're spread out all over the place. What do you do with these things? You may need to return them to the factory for rekeying. So this is one of the things that we certainly want to encourage, is that as you get through your plans, Start with your long pole. Getting these devices upgraded, what is your strategy to do those? Now we are, as Susan mentioned, we are working on an ANSI standard called TR56 that is going to try and alleviate the challenge of this key management principle. And we're working hard to put that into place, but it's still going to be some time before that's out on the street, probably at least another 9 months to a year before that's available for publication. We do have this allowance in PCI, but as we mentioned, that does reduce the strength of your AES keys to 112 bits. But what you can do today, even if you're not ready to do AES PIN or AES point-to-point encryption, which is achievable today, a lot of people are starting to make use of it. But what you can do with your devices today is to get in those stronger terminal master keys or key block protection keys so that whenever you are ready to start doing AES PIN down the road, you have that key in place so that you can remotely update your transaction keys down the road. So look at what am I doing with either my new technologies or the new devices I'm rolling out, or what am I doing with my repaired devices when they come back to get fixed? Can I upgrade them so that we can actually have those keys ready and make the updates down the road? Same sort of thing from an HSM perspective. Again, we know it's a little bit easier to get your hands wrapped around them because they are typically in data centers. As soon as you possibly can, get those devices making use of AES master keys inside of them so that you can start protecting your keys that are stored within them with AES at the highest possible level. We've hinted at the fact that we think to really get the industry to move, because we're not necessarily going to move without impetus from the externals. How do we do this? It's our opinion, for those of us on the stage here, that if we're going to do this quickly, we're going to have to maybe consider whether or not we exclude the existing estate, or if we don't do that, when we put these mandates in place, we need some sort of phase strategy that, yes, okay, new stuff, repaired stuff, it gets new keys right away. But everything that's out in the field, that's going to take us some time, and we need to recognize that. And this is just an example of how similar type changes have been done in the past by putting in these kind of targets of change 25 or whatever percentage of your estate a little bit at a time. In conclusion, I think we wanted to wrap up with a few points to just remind you, head home, is that it may not feel like it, but the AES transition has begun. 25 years after single DES was publicly cracked, we still have single DES lurking around in all the corners of the banking system, and we've got to get it out of here as best we can. And we feel that mandates are unfortunately going to be needed to encourage the change within our industry on a timely basis. The basic tools to do it are in place, but not everything is finished. But you can do stuff now. Know your systems, get that figured out, know your hardware, what you must support. If you can, get your transport keys and master keys updated as best you can, and start using AES whenever you can, but make sure you test it out for interoperability's sake. That's it. If you have more questions for us, there's a lot behind this presentation that we can definitely add to it, so please hunt us out, and we'll be happy to help you out. Thank you.